weekend?
Yes, it is good. Means I was able to do kind of like a lot in EDA. Means it looks good. Means kind of like we supported a lot of assumptions that we made while we were doing some imputations and everything. So seems like KNN imputation is indeed really it's a really good strategy, because when I was going deep down looking at different categories, I was looking at there are means the building types. It's being repeated for kind of like every year factor. So it's kind of like if one value is missing in one of the year, that means the same building is going to occur in the next year, and that we means KNN is kind of like group them together and pull out the value very easily. So so which means KNN would work absolutely fine in that particular scenario. So which means that strategy was good.
Nice.
Okay. Hi, Imran.
Hi. Hi guys.
Hello.
Hi,
morning, good evening, wherever you are.
Yes. Okay, so we'll wait for
yes,
and then we'll get started. Meanwhile, Imran, can you give me access to share my screen?
Yes. I have one slide to cover, but yes, I've given you access as well. Allowed to as well. Where is Komal? For a minute. I think we should get started. It's unfair for others to wait for so long. Let me share my screen very quick. Komal just messaged me because she's our project manager lead. She has to show something. She's just joining right now. There she is. All right, everyone. Good morning. Let me share my screen. Can you guys see my screen? Okay, good.
Yep.
Good morning, everyone. Today is our first meeting for exploratory data analysis. And there's a few announcements I need to make before I'm going to pass it down to our task leads. First of all, those who joined later on in the project, just FYI, our task lead for EDA task, exploratory data analysis task, and co-lead is Salman Khalik and Rich Gregson. That's just FYI. And I would like to inform you all, our project management lead, Komal Malani, she has created a GitHub repository in which she has created some stuff for us. Komal, do you want to go over it? Or I can talk briefly about it. Komal, are you there?
Yeah. So shall I share?
Yes, if you, or maybe, yes, or
just,
maybe.
yeah, so it's very basic. Give me a second. Yeah, you can. Yeah, so like many of us requested that we need some a place where we can see all the tasks and we are able to pick up the task and contribute. So we decided to go with the GitHub projects portal. So we have created a Kanban board kind of a structure. So as of now, we have just added EDA related task, which Salman has given the list already. So all the tasks related to a phase and going forward will be added in to-do list. Okay, and if you can open one of the tasks, Imran, for me.
Which one you want to
do? And anyone in the to-do or in progress also, because
I'll just open all. So, okay. Yeah. So I guess this is what needs to be done, right?
Yeah, so yes, so every task has information about on a high level what has to be done, and also we are trying to add corresponding reference material. Like in the first two tasks, Salman and Rich had shared some links from Kaggle to know about univariate analysis. So I have added those reference links in those tasks. So we can go through them and start applying on our data set. If you see on the right hand side, so this has the information about the task and the reference material to learn. And then whenever we are starting to perform a task, we have to assign it to ourselves. You see now the assign is just me. So we have to start assigning. Yes. Imran, can you add more people? Can you add maybe anyone or yourself?
There's no favoritism, just something some of the participants, you know.
I'm just saying if you're, so it is,
why is it?
I think it's just replacing, it's not allowing us to add more than one assignments.
Strange.
Yeah, we have to figure that out. Then it will be difficult for many people to work on it. I mean, they can work on it, but it won't be visible to us in this way.
Let me see. Let me see. Okay, that's a little, well, I guess we are also trying and testing out different things as well.
Yeah.
Okay.
So, okay, in that case, I'll just explain the overall flow. So whosoever is working on it, they have to pick up the task and assign it to themselves. And the task has to move in progress state. Like I have already moved two of the tasks you see, univariate analysis of categorical data and the numerical data. So once we are done with the task, we have to send it to review. So we have to talk with like task lead, how do we want to define the flow of done here? If anybody says I'm done with the task, And shall they already merge the files, and you will review how shall we define the done here?
Okay.
And review has to be done with the task leads, and eventually the task is finished.
Good. Thanks, Komal. I guess something maybe you and I need to discuss on back and how we can maybe make some modifications so at least people know who is doing what. Because if there's only one person can be seen, so I guess something we can discuss how we can address that issue. But in any case, it should give an idea of to everyone that what task needs to be done or what tasks there are one to expect to do, even for your own self-learning as well, in as far as exploratory data analysis is concerned. Anybody has any feedback for us or something Komal can improve upon on that, or something to address your needs?
Yeah, I like it. It's a good idea. And as you say, Imran, it's it's good to see each step broken down within EDA. So if someone's doing it on their own kind of thing, just a beginner who doesn't isn't going to is seeing this for the first time, it's good to see each step breaking down into little sizable chunks so that you can get the head around it. I like it. It's a good, it's a feature of GitHub that I didn't know existed. So it's really good. It's really good.
It is actually really good. I just found it as well. Thanks, Komal, for finding this out.
Yeah.
I think this assigning part, it's kind of like anybody who has done that particular assignment, what they can do is they can assign themselves to that particular task and they can submit the issue for that. And then if anybody else wants to do that, they can come and they can assign themselves and they can issue. I think it would work that way.
So all of these are defined as issues only. You cannot see them otherwise. Mm-hmm. But once the issue is finished, how will we reassign it?
Means I think anybody who can go on that particular task and they can change their name, assign themselves. And if they want to submit something for that particular issue, I think they should be able to do it. I haven't tried it. I'm just kind of like thinking out loud.
So see, first, initially when I was thinking if you can divide the features, but it's very tedious. Like one person is doing on first set of numerical variables, then I can have different issues created for, suppose I'm just talking about the temperature variables for numerical data. So one issue would be analyzing blah, blah, blah for the temperature variables. And another is analyzing, doing a univariate analysis for second set of variables. Something like this, that then can have different issues. But if I talk about moving same issue to different people, then suppose I'm talking about the numerical variables, second issue. So it has already crossed the life cycle, right? I finished, you reviewed, and it is done. Then how the second person will bring it again to the in progress, change the name to assignee. This doesn't look like.
Maybe we should try submitting one of the issue and play with it. Yes.
Sorry, Salman?
I'm saying maybe we should just submit one of the issue and just play with it, see what it does, whether it lets us assign another person to that particular same assignment or something.
Yeah. It will be possible. I can do it right away. See, here it is. As of now, we are not connecting to GitHub. As of now, it's just a visual representation of task. So, Imran, if you can just drag, it's just dragging the task to review. Just pick a drag, okay? As of now, we have not connected GitHub to it because first of all, I have to learn how to do that, and also we have to define how do we do the review and done process and everything. So this one is just moving task here and there. So I can definitely bring it back, assign it, and person can start working.
Mm-hmm. So what if, let's say, somebody say rather than doing 4 tasks on a right hand side, somebody say, okay, I just want to do hypothesis testing and Z testing, and that's it. That's all I want to contribute right now.
Yeah, so that's what I was saying, that we might have to maybe create subtasks further. Yeah, like even for numerical variables, there are 50 odd variables, so I might not be able to do all the analysis on 50.
Komal, I think the one where multiple assignees will be shown up, it's only for the paid versions of Kanban, I guess.
Oh,
So this is the free version. So I think it will not let multiple assignees because the version control is completely different on the paid version versus the free version.
thanks, Manasa.
So
I think
that-
that's what it is.
Yeah, that is the reason.
Mhm.
Well, in that case, maybe we can, Komal maybe can create some other doc where people can just manually just type and then say what they have done, and then another
Okay,
field where
that-
people
that
can,
is-
something we
that-
have to brainstorm on backend now.
So
Yeah, we
another
will-
thing that can be done is, Imran or Komal, we can just create branches. Whoever is working on their own task, that we can just list down the task in the doc, and whoever is doing that, like they can create their own separate branches, and they can commit the Git into the GitHub repository, and later whoever is reviewing can review and pick up stuff from there and just merge it to the master branch.
Yep.
I know it's a little difficult, but yeah,
So,
that's the only
that is
thing
how
I see here.
eventually will be done, right? If I have to merge a code, I'll have my own branch created and merge it, right?
Yeah, that's right, Komal. But here in Kanban, I think that's different, I guess.
So maybe just like we said, for having an overall view on what are the different type of tasks, we can still keep these tasks, and once the task is overall done, we can move them. But individual person handling the task can be done in the background, and merging and all has to be done and reviewed by Salman and all. We can still keep this view on for us to know what all we have to do.
Sounds good.
Yes, sounds good. Let's then brainstorm
And
on
keep
that.
the merging part as we already have for GitHub. It's the normal process that we are not defining anything new here. Right, Manasa, for the GitHub merging?
Yeah, that's right. But here, the only thing I brought up the branching is because of the multiple assignees are not possible here.
Yes.
Anyone else have any feedback on for Komal?
Means I think we did Miro that day, right? Miro also does that as well.
Oh, really?
Kanban board on that very easily. It has built-in template, and we can use that.
Oh, nice.
Yeah.
Well,
means
maybe
it has so many different templates. Means Kanban board is one of it. We can make it, and we can use it if GitHub is not kind of like giving us that option. And since we are already doing the branching thing, means everybody can create their own branch, because it's simple. They just go to task 2 and upload a file, and then at the bottom, instead of merging in the main, they just create their own branch with their own name, and that would be pretty easy to kind of like do. So if anybody is doing that branching thing, then we can use Kanban this way, or maybe on Miro or whatever. That should be fine.
Okay, that's good. Thanks for sharing. Maybe Komal, do you mind just pasting these on Miro later on? Let's see.
Yeah. So the only thing, if Miro is giving us an option to assign multiple people, right? That's the only reason we would go to Miro, right? Because
Miro, anybody can go and anybody can write whatever they want, wherever they want. So which means if anybody is doing any particular task, they can go and write in that particular board over there and update it.
But it should be same for here also. We shouldn't have any different. Anybody can go and update the task also.
Yes, it's just like in the first meeting, everybody was able to go on the Miro and do or write or whatever they want to do, so they can do that. It's kind of like all based on what settings you are doing. You are what you are allowing all the participants to do. Based on that, they would be able to do whatever you would allow them to do. Yeah.
Okay. Well, let's discuss more that as task leads and backend now. I think we should keep our agenda rolling. Anybody else has any feedback for Komal? You can message her or us privately as well if needed.
Yeah, sure.
Okay. Well, thanks, Komal. I think it's a good start for sure. At least people can definitely get sense, at least even the beginners, they know what to expect in exploratory data analysis, and then they can start their own. And task leads have also posted in their respective channels appropriate links for help where they can follow. So that should still be a good help, at least to make that framework. Okay, the second announcement is, well, I request everyone, help us to help you out. There are project evaluations posted in the announcements. I'm still opening that up for you. we would thoroughly appreciate if you can just fill that out. It just tells us how's your experience going on in projects so far, what things worked out, what didn't, and if you want some improvement, please tell us, so at least we can tailor our strategy to better help you all. I'm sharing that link in the chat as well, so please fill it out. And third announcement is our task leads, Rich and Salman, have created a YouTube channel for our project. For your convenience, you just go and just watch these videos as well over there. And since they put so much effort, I encourage you all to please support them and subscribe to that channel to stay updated with the our lecture recordings and all these videos as well, which we'll be posting. So I've posted.
Yeah, the brainstorm one meeting is being uploaded as I speak. I accidentally stitched the parts the wrong way round, so I had to delete it again. But it's uploading right now. It should be done in about 50 minutes, so you can watch the brainstorming, because there's when I reviewed it, there's a lot of good content in there and some good ideas that we may have misplaced in the journey. So it'll be helpful for people to revisit it if you haven't seen it already.
Oh, definitely. Thanks a lot, Rich, for creating this channel. It's also good actually for all of us are on YouTubing all the time, so we can just go in one stop and just watch all these videos. So thanks a lot for creating it. Sorry, I'm trying to speed things up a little bit. So YouTube is done. Also, we have a task lead for marketing. She has created, there's a LinkedIn page. I also encourage you all to please help support her. She'll be posting a lot of good stuff over there. We have a LinkedIn page of Omdina Philadelphia chapter, and she'll be putting a lot of posts. So please, I encourage you all to please show your support by just following the channel. I'm also posting the link here in the chat. Where is it? And lastly, there is an announcement. Luckily, we have two participants who stepped up as leads, who are taking care of our testing data. So that will be a great help. So they have done all the pre-processing part already. And on that, Manessa, there's a participant called Manessa, and there's another guy, Mac. They both are working. So maybe they can update us. Maybe Manessa can start and Mac can support what she said. Manessa, can you update the team on that, please?
Yeah, Imran. So what I started doing is, like, as per your suggestion, so whatever was done for the training data in the task 1 pre-processing, so I followed the exact same step for it. So I was doing on my local host, and I ended up in error due to some versioning of scikit-learn, I guess. So that's the reason I switched on to Google Colab. So I didn't find any errors there. So it went well, and I created the after file after the processing was done, after it was scaled, after the data was scaled. So if that was the ask, right?
Yes. Do you mind showing us where your stuff is, or if you can give if you feel comfortable? Otherwise, you can just.
Imran, my laptop is on Windows Update, and I'm trying to turn it on from morning. It's updating.
Okay, no worries. Maybe you
can Mac asked as well, but yeah, it's updating. So once it's done, I can actually share the. I think actually I shared the files with you, but I can
with the whole team. Yes, I have it.
Yeah, I can. Yeah, I'll share it like once my laptop is done updating.
Okay, good. Thanks, Manessa, for taking the lead on that. Mac, do you have something to add?
Yeah, I could tell you briefly about the test set data if you'd like.
Please.
Okay. If
you want to show something, I'll stop sharing my screen if you want.
I can just tell you, it's just a few observations.
Okay, please.
I just copied over Rich and Salman's notebook code directly into a new notebook and applied it to the test set to see what it would tell us. I guess first, in terms of missing data, there's 4 columns that we saw significant missing data. Those are the 3 wind columns and 1 fog, days with fog column. Those are even more missing in the test set. It's around 90% missing data. I'm not sure what that means about imputation. Should we like combine the 2 sets and impute them together or something? But there's a lot of missingness in those 4 columns.
Well, would it be nice if you could show those missing value ones if you have it ready? If not, would be interested. Maybe on Wednesday's meeting, maybe you guys can show as well. Maybe you and Minister, so at least we get an idea.
I think Mac has uploaded his version. But did you upload Mac somewhere, because you talked to me and you look good, or did you share it with me on Slack?
I shared it with you on Slack. I can just share my screen now if you'd like. And
Yes, at least so people know where we stand.
Sure.
It'll be helpful.
Let me. Okay. I'll share this notebook in a minute with the chat. On the top are the test set missing values for the same columns that we found missing values for in the training set. First, we have year built. In test set, we have about 1% of missing values. I guess if we're going to delete 2.5% from the train set, we might as well just do the same. And then we have energy star rating. We have 23% missing compared to 35% missing from train. And then for these 4 columns, we have 88 and 93% missing values.
Wow.
Moving on.
That's quite a lot. It depending on what Salman finds are. As I've said earlier on, when I was doing the simple imputer, a lot, the wind direction, 90% of the values were just just 1. So it's whether or not we feel that they are important columns to what we're trying to do. Because if there's 90% of them missing, so is it really going to affect our data?
Only the fog column gives a good correlation with EUID. Other than that,
okay.
None of these columns give us good, because more than 90% of the values of them are just 1. And there are very, very, very few values which are kind of like 340, 45, and 360. Other than that, all of the values are 1. Which means it's kind of like very few days out of 75,000 rows we have. There are only you can count them on fingers that many days where the value is not 1. So other than it is null, otherwise it would be other than 1 in those simple values or only values. So which means it's a good thing that we can drop it, because it's not bringing in a lot of variability in the data. And I don't think because all the ones and out of 75,000 values, if there are only 10 or 20 values which are kind of like other than 1 and rest of them are 1, which means it's not bringing anything into the data.
Yeah, I agree with that. It's not very inspiring, is it? It's not going to tell us much. But if there is a relationship in the fog one, it'd be interesting to explore that in the feature engineering, see what we can do there.
I was trying to figure out the relationship between these variables with the kind of like some other variables. I still haven't dropped them, but I'm still kind of like trying to see what kind of a relationship they have with something else in the data. And based on that, if we can do something about it. If not, then the final thing would be just drop them.
Yeah. Cool.
And one important thing, for example, like since our test data does not have EUID column in it, and we cannot have access to it because it is on Kaggle, and the competition from which we got the data, that competition is not accepting submissions now, which means we cannot test our result based on that test data. That means we need we cannot merge it with our trained data. So that means we need to kind of like split from the training data. And test data is kind of like we wanted to see what kind of information we can get out of it, and maybe use it for imputing and encoding our trained data. But since they are kind of like telling us the same story, which means test data is something we can just completely 100% drop right now.
Oh,
yeah.
Okay. So.
But that was good thing, because what I was able to do, I did not thought about it. One thing, for example, like when we kind of like merge the categories for the facility type, so that was giving us a different distribution, the test data. So based on that, what I did is I basically changed the strategy for adding those categories. So I updated the category, kind of like all the categories. Out of those 60, I created 14 of them. So now those 14 are very similar, because what I did is there were a lot of them which were related to universities. I kind of like put all the universities and education related things in one thing. And then similarly, I think background noise. Okay. So I thought somebody was speaking.
Yes, I don't know who.
Okay.
So, hey guys, also just a heads up, it's this meeting about to end, so you guys will have to rejoin it.
Okay. So can I start my presentation?
Yes, actually what you just said in the end, it will be helpful if you could show in your findings as well, so at least everybody's on the same page. But it was helpful for that Mac and
yes, it was.
They showed us then it's not worth
Definitely.
it. So at the early stage, now we know it's not worth it to take that route, and now we have to split it from training data. So thanks to both of you. At least it came on the right time.
Yeah, definitely. It was a good observation. Yeah,
very
superb.
Yeah,
definitely.
Can I share like two more things briefly?
Sure.
Okay. I did the SweetViz notebooks here for the two sets. I'll just share a couple things from them.
Please.
The most important thing might be that in train, two-thirds of our data came from one state 6 here, and that state's completely absent from test. I don't know, it's a little.
Oh, damn. Okay.
Odd. Other than that, the commercial residential split is comparable. The building classes are also comparable. I don't know how to do a stacked bar graph here, so it looks stupid. The other thing is our test set. It might be different partly because it might just be a higher elevation, and maybe that's to do with a missing state. It doesn't get as hot, and in that column there's only one unique value. Well, there's fewer unique values, which you'd expect for a smaller data set, but for days above 110 here, there's only one value, which is 0. There's no days above 110, so it doesn't get as hot in our test set, and it seems significantly different from the training set. That's all.
Yeah, it's interesting to see the year factor as well. There's only one unique value in there, so it must be a sort of chunk taken out of a particular year. You know, when buildings were built.
If you look at the years, the training data for this is the first 6 years of the data collected, and the test data in this original setup is year 7. If you end up digging further into the data, you can see that you could actually track individual buildings in some of these states across multiple years. There's a lot of weird, but there's also a lot of weird things going on in the data that I have found that I don't quite understand what I'm seeing. I don't know if there are errors in the data or what was going on, like buildings changing elevation. Like my understanding of elevation would be elevation above sea level, but like there's a couple of buildings that go from like 3 feet above sea level to 400 feet above sea level, and they appear to be the same building. It's very confusing. Maybe I'm looking at it wrong, but yeah.
No, I noticed the same sorts of things, Michael. It's I suppose that's the beauty of a real data set. It's an absolute mess. It's up to us to get through it, but yeah, it's there are a couple of strange things, and you know, if we were going to apply our models onto that test data, we would have to revisit a couple of things that we've done, change them slightly to go against that. But that's the beauty of the game, isn't it? It's just maintaining a model to work for unseen data. But as you'll see in the later stages, I've got a couple of things lined up that might help people's understanding of building a model and how to do it effectively. But yeah, Salman, I was going to say I don't want to take any more time up by just talking all day. So yeah.
Why don't we just start a new meeting now, because I think this one is about to end anyways.
Sounds good.
Oh yeah, it is. Yeah, 4 minutes. Yeah, that's right.
So let's turn it off and join again. Sounds good?
Yeah. Cool.
Imran, can you enable screen sharing?
Yes, sir.
Okay. So, should we start?
There's supposed to be 15, 16 participants right now. There are 10, 12. Cannot see it anymore. Yeah, there are 12. Just wait a minute and then get started.
Sound good?
Yes, I think just go ahead.
Okay. So with EDA, basically, I followed exactly the same steps that I broke down the whole task into. Started with univariate, numerical separately, and then categorical, then went on to the variate and creating correlation matrices, heat maps, and things like that. So I found several different things. For example, I started with the same exact strategy. I did not bring in the test data because test data does not have EUID, which means we cannot use it in that particular manner. So it is pretty much the same stuff from the previous thing that we did. We just looked at different data types. One thing I realized is year factor. Either we can convert year factor into a time series. We can just assign a year to it, maybe 7 years back, and create a time series out of it. That's one thing we can do. Or other thing is we can just create year factor as one of the categorical variable. So if year is year factor is 1, that means it would be because we don't know which year that is or something like that, and in which order they assigned. Ideally, it should be in the order the way the time series is. For example, if it is 1, that means it should be the farthest away, or if it is 6, then it should be the closest one to this particular year, something like that. So since it is not clear, what we can do is what I did is I just converted into a categorical variable, because this way we can kind of like deal with that. Otherwise, if I'm assigning 1 to year 1 and 6 to year 6, that means I'm kind of like giving more weightage to year 6 as compared to year 1. So we don't want to do that. So we can just, since it's kind of like a label encoder, you have kind of like created labels in one single column. What we can do is we can just do one hot encoding, and that way we are not assigning more weight to one particular year as compared to the other one. So that's the reason why what I did is I basically changed year factor from a numerical variable into a categorical variable, and then at the end we will encode it and using one hot encoding. So this is I kind of like wrote down all my analysis that year factor 6 would give more weightage to year 6 as compared to year factor equals 1 would give less weightage to year 1. So we don't want that. Then year built, what I did is basically I figured out, if you look over here, year built is 0 years. 0 years means means maybe that is wrong, or maybe it is kind of like developed the same year the data was collected. Maybe that's why it's 0. But I assume that it is kind of like a sparse data or something kind of like a random 0. So what I did is basically I just removed, since it was just one single value, I just removed that. So which kind of like gives all the year, which are kind of like pretty much the average. You can see the year built, it is giving you 1952, which means it is about 50 plus years age for every building. There's only one building which has 0 years of age, which is kind of like odd. So I just kicked that out and dropped it. So, and next thing we did is direction maximum wind and direction peak wind. If you look at the mean value, if you look at the minimum value, 25 percentile, 50 percentile, and 75 percentile, all of them are 1. which means more than 75% of the data is just one. There are very when I counted, there are very few values. For one variable, it was just 8, and the other one was something 10 or something. So that means there are just 10 days out of 75,000 values rows we have, which means this particular column kind of like looks pretty vague, and we can just simply drop it. And in the test set, we have seen that it is not bringing in a lot of information, which means if we drop it here, and if we were using the test set, that dropping would have worked pretty fine. So, and then days with fog shows a good correlation with EUID, the values which were present. So what we can do is, one strategy is we can assume that the days where the value of fog is missing, we can assume maybe that day the fog was not there. Maybe it was 0. So we can just replace the NaN values with the 0, or we can just replace them with the mean or the mode or whatever the value is common or something. So we can try that, because day with fog, when in last time we did some features in a kind of like importance and feature selection part as well. So based on that, and based on what I did today, I can see that days with fog is showing some sort of a correlation with several other features as well. So which are kind of like correlated with EUID. So which means we want to kind of like keep it in the data set and try to work out how to get the values, because days with fog have 60% missing values. So 60% is a lot of values which are missing. That means now we need to kind of like come up with a good strategy. What I am thinking is, we can assume, one assumption is we can try using hypothesis testing at the last stage of this particular EDA. We can do hypothesis testing whether it would be good variable or a strong variable, or it would have a strong correlation with the UID or not. We can test using simple chi-square test or other tests. Okay, ID column was technically, we can use it as an index, or we can just drop it, because ID column is just 75,700 values.
Sorry to interrupt. If you don't mind, if you can a little bit slow down your pace. I'm afraid there are some newcomers, they might be struggling. I'm assuming that. Just a slow pace, slightly slower.
Okay. So the ID column, if you go back here, you look at the extreme right, this is the ID column. This ID column, it looks very similar to the index column, because it is kind of like the index. If we want to kind of like assign this ID column as an index for this particular data frame, it would do exactly the same stuff what the index right now is doing. So which means this is also not bringing any information into the data, and it has no correlation whatsoever, because we have 75,757 different unique values, which means every single value is different. That means it is just counting from 0 to 75,756. So which means we can just drop that. So what I did is I basically ended up just dropping that column. Because all the analysis we are going to do, we don't want extra column to take up memory space and things like that. So I just dropped it. Next thing, year factor. I said that we analyzed that year factor is kind of like if it is 6 and 1, it would change the weightage. So I just change it into the string type. When I change it into string type, then I rerun the information. I can see that now we have 4 categorical variables instead of 3, and all the other variables are exactly the same. And I also take a look at different data types, that for some cases, you have to look whether the value, the decimal value would make sense for certain variables or not. For example, you can see, you can think about that, why not just convert all of the numerical variables into a float or integer or whatever. That's not right, because we have to take every single feature, one feature at a time, because some features, when I'm talking about number of days cannot be in decimal. So it can be either 1 day or 2 days. It cannot be 1.5 days or something. So it was means so for example, like elevation should be a float. January minimum temperature can be a float, which means if it is an integer, that's fine. But if I want, I can convert it into a float. That should be fine. But some variables, for example, like days below 30, so this should be integer. It should not be a float. So I just take a look at all the data types are technically fine. We don't need to change anything. So I just take a look at it. Yeah.
Why it just has to be integer, days below 30 Fahrenheit?
Because number of days, when you count whether on day number 1 it was there, on day number 2. So which means when we are counting number of days can be either in integer form, right? They cannot be in decimal form, which means they should be 20 days or 20.2 days. How can we calculate?
Oh, okay. Oh, sorry. Yes, makes sense. I think
So,
Varun asked a question on chat.
days
Already.
with fog is in float here. Yes, we can convert it into integers. So yes, Varun, that's right. Days with fog is in float. We can convert it into integers. So that's fine. So this is something I missed. I did not do it. So what I did is I basically, first of all, described the numerical variables, and then I described the categorical variables using the same describe thing. So there's an option. Usually when you use describe function, what the describe function do is it only give you description of the numerical variables. It kicks out all the categorical. You can see over here, none of the categorical variables are present. So you can just include object columns. It would just give you the object one. And if you put all here, it would give you all of them together. So what I did is basically I kept numerical and categorical separately. So you can see over here, year factor gives you how many unique values we have, what are the top values for which values have the top number of frequencies. State factor, you can see state 6 has about 50,000 rows, just state 6. And that's what I think Mac was talking about when he was showing that state 6 is dominating in that particular category. Similarly, over here, you can see year factor 6 is also dominating. So when you look at, when I will show you the trend, you will see that year number 1 has limited number of data. Year number 2 has more data than that. Year number 3 has more data than that. Year number 5 has more. So it's kind of like going in increment orders. So 6 has the most number of data, about 22,000. Then residential building is taking up more than 50% of the rest of the data. And multifamily uncategorized category in the facility type is taking about 39,000, around 50% of the data. So in fact, more than 50% because, yeah. So this is what we got. Next thing, what I did is I basically year build. Remember I said year build had one of the year which has, wait a minute. Yes, so one of the value was 0. I kind of like just replaced it with nan. And then what I did is basically, I just dropped it. So when I drop it, you can see the year build column. Now it is giving you something. Now the minimum value is not 0. Previously it was 0. Now it is 1600. So which means the oldest building we have was kind of like made in or put together in 1600. So we did that. Next thing what I did is I basically year build, we are getting kind of like big values here. So 1600 or 1920 or 1860 or something. What I did is I basically converted into an age column. So I just subtracted the year built values for every single row in our data from 2022, and that gave you what is the age of the building today. So I just converted that year build column into an age column and got rid of the year build column. So this way you will have the age and the number would be pretty small, even though it is telling you exactly the same stuff, but the distribution would went from 1600 minimum to 2015 maximum. It kind of like converted from 200 years to 50 years or something. So something like that. So we can see that these were the values year built, 1843 values were total. When I dropped it and everything, it kind of like dropped only and only one value. So where was it? I think it was in this one. Okay. So you can see 1837, and here you are kind of like getting the same thing. So which means it kind of like dropped, just means when I counted it, it just dropped one value. So which means we did not lose a lot of data. 1843, we had 1847, which means only 4 values, not 1. And then we are left with just kind of like these variables: energy, star rating, direction, max wind speed, which most probably is not bringing anything into the data, into the variability of the data. Direction, peak wind speed is not bringing. Max wind speed is not bringing a lot of stuff. Days with fog is something we need to look at. Energy, star rating we need to look at, but we need to find more kind of like support for getting rid of these 3 variables, the wind one, because we have a lot of missing data for them, and the values already we have for them is kind of like not variable enough, because there are a lot of ones in them and have very few other values than 1. So which means we have to kind of like support them using, we can do hypothesis testing in the end. So I'm not dropping anything right now based on just what I'm looking at. So we are kind of like doing the long route. We will do everything step by step, and we will back everything based on different statistical tests. So next thing, what I did is update the null columns. You can see I just dropped that one, then extracted the list, and I just showed it over here. You can see that days with fog, yes, there are some values which are kind of like overlapping with these 3 columns, but there are some days when the fog is there. When I was reading about the theory between the relationship between wind and fog, usually it's kind of like they are related. But in this data, you can see that over here, this is the values are present, but the fog values are missing. Over here, the fog values are present, but the wind values are missing, which means this data is showing that there's kind of like, if we think about that, maybe one instrument is usually responsible for collecting the information for these 4 variables. That instrument is not common for both of these things, fog and wind, which means there's no kind of like correlation in that manner. But we can still see something that when I was reading the theory, yes, they have correlation, because winds definitely create certain fog or get rid of the fog or things like that. So we have to kind of like work on that. So I converted year built into age column. That's what I was talking about. As you can see at the end, now I have added the age of every building. So once I added this, then I got rid of the year factor from here. Yes, I dropped it here. So I dropped year built and I created the age column. So when I created that, so that means we still have exactly the same columns that we started with. And what else we did is the ID column is what I dropped as well. I think I did not drop it before, and now I dropped it. So we have 63 columns now. And univariate analysis. Now what I did is basically one variable at a time. So look at one variable and go deep down in that variable and extract every information. For example, I started with the facility type, because we had 60 different facility types, and you can see that this is taking up more than 50% of the data. This is the biggest category. If you look closely on the names over here, you can see there are a lot of them which are warehouse and different kinds of warehouses, which means we can combine all the warehouses in one single row. When I was doing it, I was looking at the data, just the warehouse part, and I was kind of like, for example, like over here, I was looking at floor area greater than this value, means I was kind of like zooming in, and I was kind of like looking at the data, whether if I'm merging it, whether it is giving me kind of like similar values, because if the EUID values for those particular variables which I'm merging or grouping together, if they're different, which means they have kind of like different kind of information, which means I cannot merge them. I need to keep them separate. So what I did is basically I kept on doing that. So this is something I played around. This is the last kind of like code I wrote, but I kept on changing different variables here, and I kept on looking at different things. And based on that, what I did is basically I kept on writing down here. So I said that there are some lodging ones. So anywhere that I see lodging, I combine them and made them in one category and I called it lodging. Anywhere I see education, they had pretty much same exactly information. What I did is I basically combined them and put them in one category. Similarly with healthcare, public safety, public assembly, food, retail, warehouse, and all these things. And what we ended up with, out of 60, we just got 14 variables. And when I plotted those 14 variables, you can see over here, these 14 variables. So what I did is, these are the 14 variables. So you can see now I have multifamily, which was kind of like about 50%. You can see more than 50% over here. Then the second one is the office category. Then the next one is education category. Then commercial, warehousing, lodging. So we still have so many over here that you can see over here. These ones, public assembly and anything below that, they are bringing less than 1% information in the whole data, which means if I want, I can converge, I can make a group out of them and reduce these 14 into several, for example, like I would have 1, 2, 3, 4, 5, 6, 7, 8, and total 9 categories. But 14 is just fine. So let's keep it that way for now. If our model is kind of like taking a lot of time or something, we can work on, or maybe we at the end when we are doing feature selection and everything, we can run PCA on it, and we can kind of like pick up the 2 or 3 components and just reduce these 14 columns into further small columns. So we can do that. Then I compared the year factor as well. So you can see that how many unique values, 6. You can see the number 6 is bringing in about 30% of the information. Number 5, 24%. Number 1. So it is kind of like in that order. 1, 2, 3, 4. It is perfectly in that order. So and then over here you can see state 6 is a lot. And in the test set, you can see that when Mac and Manasa was talking about, means we saw that state 6 was missing 100% in the test data. So since we are not dealing with that test data, that means right now we will stick with whatever data we are dealing with, and based on that we will make our model. And yes, here state 6 is dominant, and we cannot do anything with that. We cannot drop it because it is majority of the data, and which means this is the dominant one, so we will keep it. So state 10, you can see state 10, it had about, I think, very few, about 85 values, I think. I calculated somewhere. Okay, well, let's keep it that way for now. Okay, so so yes, over here, state 10, you can see there are only 63 columns. Sorry, 15 rows. There are only 15 rows which are in state 10. That means state 10 information is very small. There are only 15 rows out of the whole column, means a whole 75,000 data, which has state 10 as one of the state. Which means I don't know what it can bring, but I'm still not dropping it. But it's better that we just drop it, because since we are not using the test set, that means we have to use the data we have. Based on that, state 10 should be dropped because it is just 15 values, and that means it is not statistically significant feature in that particular scenario. But we will kind of like do it during the feature selection. Based on that, it will automatically be dropped. So next thing what I did is basically summarized everything facility type. So I compared all 3 categories over here. Yes, there was the third category, 4th category, which was year. It is not bringing in a lot because we have kind of like data for that. I think I changed that after I made these. So that's why I did not update these graphs. Otherwise my graphs would have that, or I can just add it here and run it, or maybe I will run it later. So next thing, state vector, I talked about it. Univariate analysis for numerical variables. So I made a kind of like complete function. This is the function I kind of like picked from one of the link that I shared when I was means at the introduction of this particular task. I kind of like modified it based on our data. So I just picked it from the exact same site, exact same notebook that I shared with you. Means I was following that notebook as well. So what I did is I basically added few things of my own because I wanted to kind of like do the outlier part as well. Along with I was looking at the data and seeing what kind of outlier detection would work in that scenario. And I will show you because last time I think Imran, you were saying that if I show the 3 standard deviation one and the IQR one, both of them, so that everybody has kind of like, so I did both of them. And we will see in some of the cases, one of them is working better than the other one. So we will stick with that. So what if you see over here now, let me explain a few things. For example, like you would be hearing about skewness and kurtosis. What exactly these two things are? When you look at this particular distribution, skewness is basically about the symmetry. If you have a mean, does it look similar on both sides or not? If it does not look similar on both sides of the mean, it is skewed, which means right now it is skewed on the, or you can say it is skewed on the left-hand side, and you would call it a positive skew. Positive skew means the mean value is on the right-hand side of the median value. If you look closely over here, I made dots of mean and median so that you can see. So the red dot is telling you over here that here is the mean of this particular data, and blue dot is telling you here's the median. And you can see median is on the left hand side and mean is on the right hand side. So when mean is on the right hand side, you call it positive skew, and when mean is on the left hand side, it would be negative skew. And you can see that curve has kind of like shifted on the left hand side, which means here you can say it is positively skewed. If it has moved on to the right hand side, you would call it negatively skewed. And when we calculate skewness, we want the number to be 0. If the number is 0, that means you have 100% perfectly normal distribution. But if that number is positive, which means positively skewed, which means the mean has moved on the right from the median. And if it is negatively skewed, that means the mean has moved on the left from the data. It just tells you that. And this skewness can be handled pretty easily using log normalization or several strategies. We can just standardize it. But kurtosis and skewness together, what is kurtosis? Kurtosis basically tells you how thick or it tells you about the tail of the curve. Means if the tail is heavy or if tail is light. If the tail is heavy, you can see over here the tail is extending until this particular point, which means the tail is pretty heavy, and you can see the number of kurtosis is pretty high. The normal distribution has a kurtosis value of 3. So if a particular distribution is perfectly normal, it has a kurtosis value of 3. Some mathematical formulas, what they do is they basically calculate the kurtosis and subtract 3 from it to make it 0, so that the normal distribution has a 0 kurtosis. So when you go and search about it and you say that kurtosis is 0 and I am saying kurtosis for a normal distribution is 3, it is because of that change in the formula. So some people follow that formula. The majority of the people follow the formula which tells you that kurtosis for normal distribution should always be 3. So for simple reasons, what some mathematicians did is they basically subtracted 3 from it so that they kind of like it turns out to be 0. So they just added one thing. So when you are searching about it, don't get confused if it is 0 or 3. Just keep that in mind, that one single -3 in the formula is just changing the whole thing. So in our scenario, what we are calculating, it is 3. So you were saying something, Imran? Oh, okay. So if you look at this kurtosis, it's pretty big, which means we want to reduce it. That means when you look at skewness and kurtosis, it is telling you that there are some outliers in the data. You need to do something about it. What I did is basically I calculated. So you can see what I did over here is usually when you make a box plot, or the strategy is you kind of like find the first quartile and then the third quartile. Any data between that is the interquartile range. So I calculated the interquartile range. I calculated the 75% quantile and then 25 quantile, subtracted it, which means I got the IQR or interquartile range. And If you want to get rid of the data, the standard strategy is 1.5 times the interquartile range. If any data point is outside of it, you just drop it. But here, when I was doing that, it was dropping a lot of values. But I kept on changing this number and I kept on playing around, which means if I drop 4.5 times of interquartile range, then I will still be dropping 4,650 values, which means there are a lot of values which are kind of like in that particular, and we cannot drop it. But I tried it just to show you dropping it. So I created another kind of like data frame, and I kind of like played with that data frame just to show you. The trained data, I have not dropped these values. But for understanding purposes, I'm just dropping it. So over here, what I did is basically I just selected these values. You can see there are 459 values in total. So based on that, when I calculated, then I roughly calculated the value. I said that any kind of like floor area which is bigger than this, let's calculate how many of them are. I saw that there are only 459, which means I don't want to drop 4,650 data. Let's drop these and let's see whether it changes our distribution or not. So what I did is I basically created another floor adjusted data frame, and I dropped it. And then I kind of like, I ended up with this value, which means we originally had 75,000. Then we dropped some of the years which were missing, about 2.4%. When we dropped it, we had 7,390 something values. When I dropped 451, which means it is still 73,400 something. So that means we did not drop a lot of things, but when I calculated kurtosis and skewness, you can see the difference. Kurtosis over here was 670 something. Kurtosis turned out to be 14.04. It turned out to be close to 3, but still not 3. That means we can still play around with that number and we can bring it down further. But just wanted to show. And skewness, you can see from 6, it went down to 3. That means it is less likely. What I can do is we can take log normalization, which kind of like means you just change the scale to log. So when you do log normalization, it would kind of like come somewhere in the middle, because the big values would be kind of like very, very close to the small values. So log normalization is basically 10 to the power something. So now what that something is, because 10 to the power 1 is 10 and 10 to the power 2 is 100, which means if I'm representing using log scale, I would be representing 10 with the number 1, but I would be representing 100 with the number 2, the power. Which means now the difference between 10 and 100 from 90, it turned out to be just 1. So log normalization does something like that. Now I plotted them, and means you can see these are the distributions and everything. So it was pretty straightforward. We cannot do anything with it. So I just moved along. Next, energy star rating and elevation. I plot them together because I wanted to save the space. You can see I don't need to do a lot of stuff over here. Over here, you can see kurtosis is about negative 0.84. Yes, there is kurtosis, but this can be handled using a simple standard scalar pretty much efficiently. So we don't want to do anything with that right now. So I'm writing everything that I'm talking about at the bottom, my analysis. So when at the end we will pick up all the analysis points and we will do one step at a time, drop it, change it, modify it, scale it, or encode it based on what we are putting our insights here. So similarly with elevation, you can see, yes, the value is 8.09. Skewness, yes, there is some sort of skewness, and you can see there are 2 modes, or it is bimodal, which means there are 2 peaks here. So technically there is a 3rd peak as well. There is a very small 4th peak as well, but we can deal with that using standardization or normalization. But here you can see the tail is pretty big, which means there should be some outliers. Let's see how to deal with them. So what I did is basically, I used the IQR method, exactly the same one, and I tried it. And you can see when I do that, I'm dropping a lot of values. We had 73,000 values. Now I'm 68. That means I dropped about 5,000 values. So if I drop them, does it change my kurtosis? You can see the kurtosis did change, 0.99. So kurtosis did change. That's one of the strategy. So And I also tried, so over here you can see that in the previous one, I did 4.5 times the interquartile range. Here I'm doing 3.5 because I don't want to lose a lot of it. Yes, Imran?
Just curious, I think you said it earlier, maybe I missed it. What's your logic using 4.5 earlier and 3.5 here? I think
I'm just looking at the data. I don't want to lose a lot of data because it is kicking out some values, right? And I don't want to kick a lot of data from my whole data. So that's why I'm kind of like changing how much I'm willing to kind of like accept, means, or it's kind of like I'm allowing more outliers in one of the variable as compared to the other because I don't want to lose. So this way, if I do 4.5, I would be losing more data.
why 4.5? Why not 8.5? Why not 10? What does this number?
I tried several numbers.
Maybe I missed it.
I tried several numbers.
Yeah.
4.5 kind of like gave me a reason. If you look over here, you can see the IQR value over here, right? It is 10,347. And you can see over here, 10,347. So this is a million. So this scale is in a million. So this one is telling you million, which means I'm still taking 1.5 million somewhere here, and I'm dropping the rest of the other. You can see over here, there are very few. That's why I took that 4.5 number. So I did some, put it in my calculator, and based on that, I ended up with close to 1.4 million. So I just rounded it off and did 1.5 by multiplying 4.5. So because the graph is kind of like telling me that if I lose until here, that should be fine. So based on just that. And then when I was looking at the data, I was losing only 457 points. That means it's amazing. I'm still keeping a lot of data, and I'm able to get rid of the outliers. So that number was hit and trial. I tried several different numbers, and so this IQR number is kind of like over here, and we can just multiply it, and we can see using the graph, and we can see that how much I should drop. If you try that number, and if that number is dropping a lot of values, then change that number and play around, and then you can kind of like keep a lot of data and get rid of some of the outliers and change the distribution of the data that you're dealing with.
Thank you.
Does that answer your question?
Yep.
Okay. So similarly over, I think we did this, and over here you can see we tried that, and it turned out to be something like this, and we were dropping about 5,000 values, but still, you can see I'm using a different data frame. I'm not dropping anything from my original training data frame. So my training data set still has everything in it. So I'm just writing all the analysis and everything because we will be doing hypothesis testing and several things. So I'm noting these things down. We will run the hypothesis testing, and we will see whether it tells us whether our hypothesis is good or not. If not, then we will think of something else. So over here, I use this. So then I plotted all the January temperatures together, the minimum, the maximum, the average. You can see the kurtosis is pretty good. The skewness is not that much, which means we don't need to modify anything. Similarly, all the temperatures were exactly the same. So I would not spend time on it because they're pretty much exactly very close to 3, very close to 3, very close to 3, very close to 0. So all the values are pretty much same for the temperatures, which is a good thing. And there are no missing values. Nice. So that was also a good thing. And then cooling degree days, heating degree days, and precipitation inches. You can see that the values are pretty much in the range. We don't need to do a lot of stuff here. We don't need to do the outlier thing. We don't need to kind of like spend more time on them. So they are pretty straightforward. The values are there. We can just use them in our model. Snowfall inches, depending on whether we have correlation with the UID or not, which we will see later. So over here, you can see this is 3.64, pretty good. This is kurtosis in the quartile range. Days below these values, you can see there is kurtosis here, pretty big one here. So that means we can do something about it. Yep.
Our meeting, we need to restart, just a heads up.
Okay, so
let's restart.
So we will be restarting again, right?
Yep.
Okay, so or should we just restart?
Yep. Yeah, go ahead. Yes.
Okay.
Please.
So. Okay. So meanwhile, we are waiting for people to join. If anybody has any questions so far, please go ahead, ask the question. I can answer in that time. And Imran, can you enable?
Oh, I'm really sorry. Yes, please. Please, everybody, please be comfortable. Ask questions. When you ask questions, that's when you dig deep and you think more deeper, and that will only help you in the end. Salman has done a very good analysis, but I think to add more value for you, it's please ask him questions. Be comfortable. We all are here to learn.
Yes.
Don't be shy.
And I've kind of like I don't know everything. I'm just telling you what I know, and I would be happy to learn anything that you want to bring in, because this is not everything. There is a lot of statistics, a lot of detailed statistics that people can do and statisticians can do. This is something which I'm just using based on what I know. So I would be happy. Please ask questions. It would kind of like give me a different insight from the data, which I was not able to think about it. So I really appreciate it if you ask questions.
Yes, definitely.
Should we start?
Yes, I think so.
Everybody's good? Okay. So days above. Yes, anybody was saying something? Okay. So you can see days above 110 Fahrenheit. You can see there's only one block over here. That means we can just get rid of this particular column straight away because it is just one single value. Over here, you can see kurtosis is pretty big, and the values are, a lot of values are missing here, because if you look at interquartile range, that's 0. If you look over here, interquartile range, that's 0. That means none of the values are in the middle of the distribution. There are all the values either on left side or the right hand side on the outlier section, which means all the values can be considered as they are not bringing any good information. So for this one, yes, interquartile range is 11. This is 25. So these two, yes, we can keep them, but these two, they're not bringing any information. So we can just drop them, because you can see that kurtosis is pretty high. Over here, kurtosis, everything is 0. You can see, because that's just one single point. Now, for the wind part, you can see the interquartile range is 0 over here. Interquartile range is 0 here. Interquartile range is 0. That means there are many values. So the mean turns out to be 67.56. But if you look here, majority of the values are at 0, and majority of the values are somewhere 360. That means there are no values in the middle. So which means it's easy to say that we can drop it. The same thing over here, the same thing over here. So then days with fog, site EUI, and age, if we plot all of them up, you can see the site EUI column has some kurtosis, which means we have to look at different values. Over here, the outliers, using the same strategy. Here, I have to implement the outlier strategy because I wanted to do these correlation and everything. So we can apply exactly the same formulas that we previously did over here, and we will do that. Over here, you can see that the age category, it's pretty reasonable now. Now, there are only few buildings which are 200 and 400 years old. So we can look at the numbers of those buildings, and if they are just few, we can just drop that, because majority of the distribution over here, the mean and median, they are pretty close over here, which means it can be converted into a normal distribution pretty easily if we standardize it. And these are very few values. We can just take account of it, and if they are pretty very few values, we can just drop them. We don't even have to do any IQ or correlation thing, outlier thing, or standard deviation thing. We can just look at the count, and if that is 5, 10 or something values, means out of 75,000, we can drop it, because those 10 values are the odd ones out. So next thing, this. So bivariate analysis, what I did is I made a correlation matrix. This is not a heat map, but this is one line of code can create your table data frame into a heat map. So yes, the heat map is pretty kind of like small, and you need to kind of like work on putting it on a piece of canvas, means on the screen perfectly. But this way you can scroll left and right and everything. What I did is I basically just added a gradient over here, cool, warm. Based on the values, it is giving different colors, which means red colors are giving you high correlation, blue colors are giving you, or white colors are kind of like, or light blue colors are giving you less correlation. So you can look at the correlation of all of them. So what we can do is we can take a look at site UI and follow along this particular column. So this particular column is gonna give you the correlation of all the things with EUID, site UI. Over here, you can see the first column, which was floor area. So it has good correlation with that. Not that much, about 4.5. This one is negative 0.47. The number closer to, so correlation is between, it should be a number between -1 and +1, which means negative means it is negatively correlated or inverse proportional, you can say. If it is positive, close to +1, that means directly proportional or direct relationship. Somebody education. Belia, this particular notebook is on GitHub. We update it. Means me and Rich, we are kind of like, whenever we are done with our strategy, we upload it. I think you are looking at the wrong thing. I can share with you where to look at if you have access to the GitHub repo for our chapter. There is means let me finish this and I can tell you where to go and where you can find it. Sounds good? So
yeah,
so this site UI, you can see over here, yes, this is not that good correlation. This one is good correlation. This one is about 11 point, you can say correlation. So we can look at the correlations over here. Okay, so I did not do an in-depth analysis part on it. I was able to just put it on the file, which I will be kind of like doing it for the next presentation. So then I kind of like, this is just a table. I just plotted a correlation matrix using simple straightforward core method. And I use Pearson correlation. There are several other methods if you want to look for them. So there are several other methods as well. So there are two more methods. I think I forgot about the names, but there are two more methods. You can try both of them because they use different kind of like statistical theory behind it. And I have not much knowledge about it, so I would just skip it. So this is a correlation matrix, exactly the same thing as we did over here, but this is kind of like just clearly compact version. In a compact version, you can just clearly look that this is site UI and look for any thing which are kind of like darker or lighter. So you can see there are a lot of lighter stuff because the darker, the bluer part, which means -1, the whiter the browner part, it is close to 1, the whiter part. So we don't need to look at the whiter. So anything which is bluer, you can see all these temperature ones, they are kind of like towards the positive side. And all the ones over here, they're kind of like towards the negative side. So we have good kind of like set of variables. So there's no clearly defined number based on the given data. Sometimes there are some features which are very highly correlated. Right now over here, you can see the correlation is not that very high. Since we have a lot of features, that's why using a lot of features can give you more insight to it. But right now, you can see the biggest correlation you're getting is 0.47, I think. So with any of the sorry.
I was going to say as well, what we're going to do in the feature engineering section as well, because we do have quite a broad, site UI hasn't got the strongest correlation with the existing features. What we can do is create features with the ones that we have in our data set. So as I've suggested before, maybe combining the monthly average temperatures into seasons and
sorry
taking the mean from them.
Can somebody stop mute their stuff so at least there's an echo? Sorry, go ahead. I didn't mean to.
Is that better now?
I don't know from there though.
Yeah, so ideas like in the feature engineering section, if we've got sort of low correlations on our target variable, we can combine different features. One of the ones I thought might be a good idea would be combining the average temperatures in 3-month seasons. So you'll have like spring and summer, autumn and winter, and taking the mean of those 3 months and combining them and see how that affects the correlation. It could, because a couple of the seasonal, the monthly average temperatures seems to have quite a high correlation. So it'd be interesting to do that, but we'll get to that in the feature selection. But a correlation matrix is essential for that sort of, them sort of observations, especially when it's so visual. Mm-hmm. It's very easy to see where your correlations lie and where they don't. So all the red ones, do they need to be sort of left alone, or can they be combined to improve the correlation and improve the model? And if you combine some of your features, it also reduces model complexity, which you can also have a more powerful prediction on that basis alone. So yeah, it'll be very interesting to see when we get there.
Yep, that's right. So so these are correlation ones, and then what I did is basically I also plotted the pair plot for the variables as well. So which is also giving you a scatter plot between all the variables among each other. And you can see that in some of them, the correlation it is just visible in the data. For example, like over here, you can see there are a lot of values which are just over here accumulated. Over here, these are just values accumulated. It's kind of like not giving you a trend. If I want, I can put a regression line in it, which can give you more good indication whether the kind of like relationship is in which direction or something we can see. So you can see these are all values at one single point. So this is elevation. Let's zoom in. So over here, you can see with temperature, the correlation is pretty good. Means all the temperatures are pretty highly correlated with each other, which they should be. So since we have a lot of variables, pair plot is kind of like going crazy. What I'm doing is I'm just picking 200 samples. I think Rich shared one of the code. And I never tried it. And when he shared it, I tried it. Still, it took several minutes to kind of like give me this table. So what we can do is we can use maybe a pair grid, which gives us the opportunity or that we can just pick and choose the X and Y values. Pair plot, it is not modifiable. It picks up all the X and Y. It puts all the variables on the X and on the Y. But pair grid, you can pick and choose. So what we are going to do, what I would be doing is next is I would be doing one variable at a time. So I will be plotting one variable as compared to the other one at a time. And this way, it will not be computationally very extensive, and it would be able to means we would be able to kind of like pinpoint about one single variable easily. But here, since this is kind of like not giving you correlation between, so what I did is I had 60 variables, and it was taking a lot of time. I kind of like divided it into all the temperature columns separately and all the other columns separately. And I kind of like plotted both of them separately. Right now we can see which variables are related, but we cannot relate the variables which are temperature related or the other one together. So we have to do that. So that is what I would be doing next. So for today, I was able to do until this particular point. But I think that's it. So next step is doing all the assumptions that we made, all the insight we gathered. We need to kind of like do some testing, maybe ANOVA or some different testing, chi-square or t-test or z-test or whatever. Based on that, using our hypothesis, we will test every single hypothesis that we thought of, and we would see whether they are accepted or rejected. Or based on that, we can just drop several columns, and this would make this particular step pretty kind of like less, you can say, processing extensive. So I think that's it for today from my side. If anybody has any questions, please go ahead, ask me. I would be happy to answer.
Just further to the point of testing, I shared a small notebook with a couple of different tests that you can perform. All you have to do is basically come up with your own hypothesis, enter in the information into the code template, and just see what happens, whether it's accepted or rejected. And if you are doing that, please make a note of them and share them with the group. It'll be interesting to see everyone's finding, because we don't really want to all of us work on the same sort of problems, if you know what I mean. So if you do run through some testing with the templates that I've provided, just let us know, and we'll make a note of them, and we can see what happens within the next sort of meeting.
Yep, sounds good. And one last thing. I think Bilia asked me where she can find the repo, so I can share that as well. So if you go to GitHub, then of Philadelphia. So Bilia, if you have access to this particular repo, you can go to this src. This is source. So if you ever forget about it, where to go and find, just scroll down and read the README. In this README, it is telling you that there's a source folder, then it has tasks, and we are doing task number 2, which means you need to go to source folder, then go to task folder. And in the task folder, this is task number 2 we are doing. So just press on it. And these are the tests Rich was talking about. He shared all the tests, all the codes. So you can use that. And this is the notebook that I just used. So both of them are here. So for next thing means there are some statistical tests. You want to run some hypothesis testing using these tests, do run it. And whatever I have done so far, it is already here.
Okay, thank you.
I'd just like to make a point as well about why we need to scale and normalize. When we've got a data set such as ours, we need to scale the values usually between -1 and 1, and that is because we've got different measurements. We've got square foot of the size of a building. We've also got temperatures as well. So it doesn't make sense. It won't make sense to a machine learning algorithm. So when we scale the entire data set, it puts every value in a scale between -1 and 0, which a machine learning algorithm can pick up. In terms of normalization, what Salman was talking about, by trying to make the mean as close as 0 as possible, that is, it sort of makes your data more, fluent to a machine learning model. Some machine learning models don't need them because they're not looking for models that need normalization. The most of the ones that look for distance between different kind of features. So it's your sort of neural networks, and it's your KNN models as well. But it's always good practice to do it regardless, because it does make your data a lot more clearer, and the outputs that your model will provide will be much more sort of coherent, and you'll be able to understand them and take a lot more from them. But yeah, that I just wanted to clear that up a bit, because sometimes it is a bit confusing of why we do them sort of things, and it's something I struggled with for a while. When do I normalize? When do I scale it? It very much depends on what sort of model that you intend to build. But in our sort of case, we haven't really, we're not going to decide on what model we use until we test a lot of them. So it's just good practice to just do it and do it regardless anyway. And I think Salman's done a fantastic job of doing that and explaining it and showing, what difference it makes, and the sort of process we have to go through to get to this stage. But yeah, it's one of them again. Once we start building the model, we might have to go back and change these sort of different things. That's just the beauty of it. But yeah, I enjoyed that, Salman. You've done a great job.
Thank you. So it's kind of like all the analysis that I'm writing. Some of the things we will do, some of the things we will not do. So when we are at the model building step, we would be kind of like trying what we right now did. And if that is not giving you a good model, you can try to hyperparameter tune them. If that is also not giving you a good model, then you can come back and you can just use the insight that we gathered and change the data based on that. I mean, some things you kind of like ignored, but some things you kind of like dropped. So maybe dropping more variables, which our data is kind of like suggesting, that can increase, because in machine learning, majority of the time, simpler is better. Because if it is simpler, always try the simple thing first, the simplest thing. And if it is giving you a good result, then why bother doing all the hard stuff? So always try the simple. So we will do that. Means we will. The first strategy would be dropping everything, which we can see that is not bringing good information, and run the model. That would be our baseline model. So we will see that. Yeah.
And in the feature engineering section, we're going to do we're going to use 3 different types of measuring feature importance. So based on our assumptions that we've got through EDA, we're going to put them to the test and see how important those features are when we're trying to predict on our target variable. And based on what we get from our 3 different methods, we can select which features to keep when we're building our actual model. And that it could show us something completely different to what we expected, but that's the beauty of it. We can then go back and revert and do a few changes, but the purpose of the EDA is to go into the next section with our particular insights and put them to the test.
Yep, that's right.
But yeah, great work, Salman. I'm very impressed. Is there any questions at all?
Everyone's good.
Yeah, must be. Must have explained it very well, Salman.
Or maybe went over everybody's head.
Thank you, Salman. That was really good. That was really nice.
Thank you.
Explanation.
Thank you. I think Imran, you were muted. You were saying something.
Yes, I was just appreciating it. It's a great work. Seriously, thoroughly enjoyed it. In fact, I'm going to rewatch it later on as well. Thanks a lot for doing all that great work. I'm pretty sure you would have been learning a lot. I think that's the best part of being a lead. There's a sense of accountability also pushes once is the best version. People usually are afraid, but I think they should take in lead because you learn the most. And yes. I'm sure Salman is enjoying that experience as well.
Absolutely. Means there are a lot of things which I did not try. Means, for example, like the 3 standard deviation thing, majority of the time I always go with the interquartile range thing. I did not try that 3 standard. I know that it works, but it is there, but it is usually there for normal distribution. If the data is normally distributed, then you go with that. But majority of the time, you don't get the normally distributed data. So which means that's why I kind of like run a lot of models. I just use 3 IQR, but here I'm trying to kind of like several different things. I worked on my graphing as well. Means I'm not good with visualization, but I kind of like pick and choose several different things and added them. So it's kind of like I learned a lot while working on it. Yeah.
No, definitely. And especially most of us either are already in industry or want to go to industry and have to do these jobs. So it's better to create these templates, work on it right now, since there's not much stakes involved.
Yes.
So please, I encourage everyone to please ask questions if there's any lack of clarity. We all are here to learn. Don't keep shyness.
Yes, and for anyone who is learning, I'm creating the functions. You can copy those functions and put them in your GitHub referring or something, because I use it all the time. I have created one function and I have used that function over and over and over again. I don't need to kind of like write it all over again. If you have kind of like made one generalized function for certain thing, for maybe outlier detection, maybe feature engineering or something. For example, like feature engineering, I have made several different samples. Similarly, EDA, I have made several different samples. So I just run them. First thing I get my hands on the data, I just run through it and get the model. For example, if anybody wants to, I haven't taken part in any Kaggle competition or something, but I know this should be the strategy if anybody is planning for that. How come people are submitting a lot of submissions? That is what they do. They have already built in templates. They just put the data in the template and see what the result they get, and they just kind of like submit it, and they are on the leaderboard. So and then they keep on going back and improving whatever we are doing. That is what happens over there. So
yeah, I've got a repository on my GitHub called Machine Learning A to Z, and it's just literally blank templates of every single machine learning model I've ever used. And as Salman said, all I do is go on there. If I get a new data set, I just plug it in and see what happens, and then go from there. But yeah, it's just a good way to do things.
It is a
at least you
pretty
get
good repository. I would recommend anybody who kind of like gets a hand on it, just go and fork it. I have forked it. Yeah.
Which one?
I'll share it to
Rich's repository?
Yeah.
Yeah, I'll share it now. Give me 1 second.
Sure, please.
It's literally just a list of all different types of machine
learning. No, that's very logical.
Models.
It makes sense, especially sometimes you want to just do a quick and dirty just to see how the data is and how to approach it.
Yeah, it's a good way to sort of eyeball a baseline, if you know what I mean. If you're not sure where to go with it, if you just plug it in. And what I also do is as well, which you'll see in the feature in the model selection bit, I create a function that will, depending on whether it's classification or regression, I make a function that iterates through about 10 different models and just scores them, and then see which one performs the best.
Oh, really?
And it's just an easy way to do things. If you, especially if you don't have domain knowledge of the data you're using, like this particular data set, I've got no idea about building energy efficiency. But what I would do is just put the data in and create a function that just ran through it, a number of different models, and just see what it spits out. And then whatever scored the highest in sort of, precision and accuracy, just work on that model. You know what I mean? It saves a lot of time, I think, and it sort of gets you to, especially if you don't have domain knowledge of a particular data set.
Yes. For example, like I have the same stuff. Means I have created a complete pipeline for regressors. For example, like over here, the complete hyperparameter grid for all of them. And then you just run it and forget about after running it, because it will take some time if the data is pretty big. And then it will at the end tell you which model did what at the end.
Yeah.
So it's just 4 pieces of code. That's it.
Nice. That's all on your repository of your own?
So this one is, yes, in my repository, but that would be named as end-to-end machine learning model. So I'm kind of like working on last part of it, deploying it on a cloud, and then making an app out of it. But regression parts, model building part, I've already done that. So I'm still working on the deployment part, but yes, it is on GitHub.
In my repository as well, with each machine learning model, there's also a sample data set you can just download with it and plug it in and see what happens. But yeah, it's, there's a saying, you shouldn't have to type code twice, and that's why you build all these templates, because they can just be applied and patched onto anything. But yeah, so when we're done, when we've done this project, and we, the notebooks that we've created as a team, it'll be great for future data sets that you come across. It could be easily adapted, so it'll be one to keep as a template. It would be a good idea to do that. So not only are we learning and working together and putting something together, we're putting something together that will benefit people in the future careers if they decide to go down the data science route.
That's
just
the whole
keep all
idea,
your
actually,
code.
pretty much.
Yeah, it's made my life a lot easier. And funnily enough, I'm interviewing this week for a new data science engineering position as well that someone's tracked me down for. So good luck on that one. But yeah, but this, a lot of the time, when you're just not sure of what to do, just run it through some templates that you've done and see what happens. And I can't, get across how important it is just to get that baseline and that basic understanding. It's helped me a lot, and I'm not 100%, I'm not a master of this whatsoever. I've learned so much just listening to Salman and listening to other people's opinions. It's just it's an industry that you'll never master. It develops too quickly to master.
Definitely.
Yes, that's right.
It's not just a matter of just telling those technical stuff. You need to have good communication skills and breaking down your ideas. If people cannot understand, it's not going to help much down the road to you anyway. So it's holistic
definitely.
Learning. Okay, I have to wrap it up. Just 2 things I have to cover. I'm noticing that our Sundays meeting, of course, there's a lot of material to cover, takes much more longer than Wednesday. So if people want, maybe, and I know it's a weekday, so some people have challenges to attend. So maybe, and I can poll if you guys want, or however, maybe we can reduce our Wednesday meeting to 40 minutes, 45 minutes, and then enhance the time of our weekend, Sunday's one, because it's off.
Yeah.
Wednesday 45 minutes would work for me, and I would be very happy with that. Yeah.
So I can send a poll on to later today, and let's see if majority agrees. Maybe we can do that, because I'm noticing today we spend like what, how much, more, hour and a half, or so that's, we have to balance it out. It's a weekend as well, so this is why. So I can send one poll on that, and I encourage everyone to please fill out the survey. I just shared a link on the chat, so that will be very, very helpful for us to tailor our strategy on how to help you guys best. And that's pretty much it from my end right now. Yes. Any other questions, anyone? Otherwise, we're gonna wrap up. How much time do we have? Okay. There's also just a quick refresher. Salman, do you let me share very quick? One slide, last slide I have. Just giving that's the timeline. We are done with week 1. We are here right now with this EDA stuff, and then we're taking up the feature engineering. And then afterwards, we decide either we want to do final presentation between week 3 and 4, or we can just pick the model deployment. So that as a team we can discuss, but trying to give a refresher of what timeline we are shooting for. That's all.
Cool. Yeah, I think the final presentation, I think that might be quite an important bit, actually, only because we can go from start to finish what we've done so far, so we know exactly what we're going to do in model selection or model building and whatnot, because there is a lot to take in, and it's just, you know, it's easy to forget a lot of detail, do you know what I mean? So just having a final presentation to quickly run through where we're at and how we're going to proceed, I think that'll be quite valuable. And
I think, for example, like model building part, since we are coming up with so many different strategies, we can try all the strategies. Means we can extend it. Why just keep it for 1 week? We can do it in 2 weeks maybe for the next part. So I think let's keep the model building part for the next second part.
So that's the whole idea, because there's already a lot to absorb, especially there are some beginners as well. Even today we covered a lot as well, and there is more coming up next week. So it's okay, sure, as long as we are on.
I want to try all the things that I have not tried yet. So I want to play around as well. So which means more time, that means we will be able to play around with more stuff. Yeah.
Good. I'm down as well. The more holistically we develop, that's better. Okay, guys, let's wrap up. I think it's enough for today. Thanks a lot for coming, and have a very good weekend.
Yeah, have a good one. I'll see you all soon.
Thank you.
Bye.
Thank you. Bye.
Bye.